Do you know how current flows in BJT? So this is the lecture where we can become a master in the topic of BJT. So let's see how the current usually flows in the BJT or a PNP or NPN transistor. So usually how the current flows in diode is very simple, because when we are giving the reverse potential or given forward potential based upon the saturation or based upon the terminology of supply, the current will vary and these kind of things will happen. So based on the biasing, the things will happen in the PN junction or any kind of diodes, means a single junction transistor. When there is an two junction which is coming there, so then the thing will completely relay differently. So let me take a here case of PNP transistor. So here let's take a example, that is PNP. So we already know there need to be a two junction. So let me draw a separation. So there are some criteria to draw this separation. So these are some research lab oriented. So we'll let you know what are the things that we need to follow here. So first thing is that usually the width of the first one, let me name that one also. So this is called as emitter. So middle one is called usually base, and last one we are calling as collector. So here we are seeing the common base configuration. So each one has the each different configuration under their requesting application purpose. So now we are going to see common base, then we can also extend our things to common emitter and common collector. So first, for our understanding purpose, let's begin the topic of common base. So here what usually our ultimate objective is what? Some current of we need to give, some current of output we need to get. So that is what the thing. So we need to make this BJT and current conducting part. So after that, the application which will be acting as amplifier or oscillator, that thing we can discuss in analog electronics. So that is a different subject. So here let's see how the functionality is working. So that is what main cut needed, because if we know the functionality here, then we can extend that part easily to the amplifier application. So let me see. So usually the emitter will be doped heavily. So you guys know the P plus, which is considered as a heavily doped. So why they are heavily doped, I will let you know once the completion of the remaining part. So I will let you know why. So then you guys will be able to understand. So the thing is that, so for now let me draw a separation for the base that is very smaller. So usually the base width will be very small. So why, I will let you know, don't worry. So the thing, so this is how the base width. So let me extend it little bit. Okay, so this is how usually the width of the emitter will be larger and width of the collector will also be larger, but the width of the base will be very small. So that is a very thin. I will let you know why. So here the thing is that we need to supply voltage, we need to get out thing. So this is as we can consider this as a two-port device. So let me first give an input supply. So let me draw an input supply. So which will be forward bias or reverse bias or anything. So each one has its own application. So let here first give the forward bias, because we need the current to flow here. So let me give the supply which is as a forward bias. Okay, so here I am going to give the positive voltage here. So that is what the thing. Okay, here let me connect it P to P and N to N. So means this is a positive and this is a negative that we are connecting. Okay, so this is for the supply. So this is plus minus, this is a voltage. So across B, E and B. So that way we'll name as VEB. Okay, so this is what the potential names, that is VEB. VEB is positive, right? So what will happen? Plenty of holes will be pumped here. So plenty of holes will come here. So the thing is that plenty of holes will go inside, as because it is positive terminal, and also this is heavily doped. So means the more number of holes will be there comparing to this one. The majority charge carrier here will be more than the majority charge carrier of this region and this region. Okay. So then what will happen? Plenty of holes will be pumped from here to here. So you guys may happen, why this is pumped again from the P, N, and again why it's going to P. Let me explain that. So for that only they are designed this width to be very small. So the WB, the width of the base will be very smaller. The width of the base need to be much greater than LP. So LP you guys know, right? The length of the holes, the traveling region, right? So this is how this much region the holes will be travel when they are when the holes are minority charge carrier moving from one to another one. So WB will also be much less than LN. So this is from PNP. This will be for NPN transistor. Okay. So this is what the thing. So if we consider the thing, then only small amount of holes which are coming here will be recombined here. So only very small number of holes will recombine with the electrons present here, as we know that the electrons are majority charge carrier here, right? So only very quite small number, because the doping will also be much greater and the width of the region also very small. So the plenty of holes will be punched to next region. So what will happen? More number of holes. Now, not if 100% of holes are pumped here, some 25 will be lost here and 75 will reach the collector region. So that is what the thing that this is doing. So this is the half of the circuit. So then here some holes are coming, so it will recombine with the majority charge here. But as this is a majorly heavily doped, the electrons here will not be enough, so that the electrons will be pumped here to here will be recombined with the holes there. So here we can clearly see, right? So holes moving from here to here. So we can clearly see holes movement and electron movement. So there is a current. So here we can state this as a, let me write in a red color. So here we can clearly state this is an IE. And here because of this electron movement, we can clearly see the opposite direction, which is IB. So this is a base current. Okay. So this is with the help of only electrons and holes in the first region. But our ultimate objection is to get a current from the collector region, because this is a two-port network and also that will be considered as the output. Okay. So because if we remove this one, then this is quite similar to our diode. So there is no application why we need to get into BJT. So for that purpose only, now let's do the second part. So that is the supply that we need to give here. So here there is two questions. So one is that we can give forward bias here or reverse bias, anything. So each has its own application. So first our thing is to make this as a working in a proper conducting region. So for that, let's take a condition. What kind of supply we can give? So we know already there is plenty of holes coming. So here some plenty of holes is coming. Some electron will need to go here, and some electron, as we know, so electron need to go here, because in order to equalize this kind of holes pumping. So the electron which is coming from here will also be recombined, and that will not be equal. So some holes will be shifting to here. So let me use the red pen itself for first current moment. So some electrons will move from here to here, and we know that already the holes are moving from here to here. So this is the understanding that we are making here. Okay. So some holes will recombine, based on that some electrons will go here. So this is from the base region that is coming. But that will not be enough to maintain the neutrality or maintain the condition of the movement. So in order to make this working perfectly, what we have to do is that we have to pump more number of electrons to the P region, because there is more number of holes available. So in order to make that, what is our condition? We need to give the reverse bias, because we need to connect negative here, then positive need to be connected here, right? So that is what the condition. So let's give the reverse bias supply here. So let me draw a circuit that we are going to give reverse bias here. So please try to understand why we are giving each potential is very important. So we should not learn it simply like they are giving reverse bias, so we also give reverse bias. That is not a learning. So need to ask question, why this is happening, why that is happening. For that only we are doing. So I am giving this as a reverse bias. So reverse bias means you goes nice, right? So P to N and N to P. Okay. So we have connected as a reverse bias. So this potential can be named as what? V. Positive is connected to B, negative. So VBC. Okay, so we are naming based upon the configuration and the thing. So which region the terminal is connected. So I hope this is understood right for now. So let me take a blue pen here. Okay. So here we could clearly see actually why we connected is in order to supply electrons from here to here. So once we done that, then more number of electrons will come inside. So there is a net movement and something will recombine. So that is will happen. So and some kind of electrons will also move from here to here, because this is a minority charge carrier. So we are keep on pumping, so will recombine and it will not be going above that. So things will go here, and then that will be used to neutralize the condition of this one. So then that some kind of things will also be going to here. So that is the thing that we have to understand here. So the thing is that, so this is the junction E, so this JE, so this is junction base, junction JC. Middle term we can ignore it. So this junction is JE, so this junction is JC. Okay. So now you can understand, right? So now excess holes that are pumped, we don't have electron to neutralize or recombine that. So for that we are giving a reverse bias and we are getting. So if we give the forward bias here, what will happen? Then more number of holes will pump here. Then what will happen? The device may go into breakdown region or even into saturation region. So there is some kind of if we give forward bias, now we are giving forward bias here. So this is forward bias and this is reverse bias. So this is the condition for amplifier purpose or the conduction purpose. So this is not even we can say this amplifier. So this is some kind of active region. So this is what the expected region of working. So I will know if we give reverse bias here, forward bias here, forward bias, reverse bias, what will happen. I will explain all things. So don't worry. So for now, please focus on understanding of how current flows in the BJT. So now the electron is moving inside. So from this region. So then what will happen? The current will move in the opposite direction. So that is the IC. Okay. So that is how will happen. The things will happen like this way only. So now you guys can able to understand, right? So how are current moving in these things? So we know that the VEB will be the greater potential. So even if you are giving 0.7, usually we give this a 0.7 here because this is a reverse bias, right? So usually this will be approximately equal to 0.7. So most of the cases it will be approximately equal to 0.7, but they will be approximately equal to greater than 2. So mostly it will be greater than 2. So mostly it will be greater than 2, 3, or like that way only given. So for that, the plenty of electrons only will be pumped here. So this will be, this contribution will be minimum only, but that is needed to neutralize these holes here. So let me explain it from the scratch. So please listen carefully. So we know that here we are giving positive terminal. So what will happen? The IE will flow because of the holes are moving to this region. So as this is already heavily doped and also we are pumping more holes here. So the plenty of holes will be moved from this region to here. So some will recombine in between in the base region and with the electrons which is coming inside here. So that will contribute some recombination current and this movement of electron will be termed as IB. So then more number of holes here, as this is already holes is a majority charge carrier, the holes are keep on increasing. So in order to neutralize that, we are giving a reverse bias supply. So in order to make this as a recombined things here. So then because of this electron movement, so then IC will flow. So this is what the current. So in making the generalized thing, we can compare it in a situation where we can do it. So here if we see, this is an IE. So this is the current contribution from here and this is IC. So simply we can term IE, IC, IB, everything can be related to a single equation. So let me draw an equation of things to understand here. So let's try to understand this one from here. So we know that IE which will be equal to IE which can be written as IPE. IP is nothing but this one. So this one can be named as IPE. The holes current in the electron emitter terminal plus INE. So which is nothing but the movement of the electrons from here to here. So this will be we usually named as. So as electrons are moving here, the IPE can be named here this way. So sorry, INE can be named like this one. So this is also this way. So both is contributing to IE. Now IC can be written with the IPC. So this is because of this one, the holes coming from there to here, right? So that only IPC, the holes in collector terminal, plus some usually will have some reverse saturation current will be there. So that will be termed as some kind of negligible nano and micro things as. So that can also be added here. That is ICBO. So that we will term like this way only. So I will let you know what this ICBO and everything clearly. So for now, please note this term. Some reverse saturation current or some negligible current will flow here this way. So this is how this can be named. So this one, the explanation for this one is the reverse saturation current of collector junction. So let me write it. So this one is the reverse saturation current. Reverse saturation current of collector terminal or collector junction. So let me name as JC. So current in JC. So this junction, right? So JC junction in common base configuration. In common base CB configuration. In CB with the emitter is open. When emitter is open. So when emitter is open. So this is some lab finded parameter. So that usually will get. So emitter is left to open means there is no supply to that. So if the emitter is completely removed, then because of this majority charge carrier, some kind of minority charge carrier will also move there, right? So that one we usually termed as ICBO. So when IE which is equal to 0. So simply we can say IC will be equal to ICBO when IE which is equal to 0. So this is an important thing. So the current is purely because of this junction, not because of the supply from the emitter junction or anything. So that is what it will resemble. Okay, so please understand this carefully. So this is completely based on this only. So that's what the thing that they are stating here. So, okay, so this is what the two majority current will mainly focus. So IB, most of the cases we can ignore it because that will be very negligible current only, but we can't ignore it. So let's take into understanding purpose. So from here we can clearly understand how the BJT working here. So in the next lecture I will be posting how we can derive IE. So what will be the equation for IE, everything I will be deriving in the next class. So I hope this is understood for you guys. So this is not a simple thing. So please try to remember it carefully. So the current contribution and movement, which will be always resembling the things how the electrons and holes movement. So the net thing is that how many charge carriers moving from one part to another part. So that is what the majority of contribution. So I hope this is understood for you guys. So if you have any doubt, please post in the comment section. So I will be helped to resolve those things. So after watching this video, I can assure that you guys are now master in the topic of BJT. So how current is flowing. So in most of the college times we may not know. So we simply take a forward bias, reverse bias, current supply and amplifier application like that way. So that is not actual understanding of study. So we need to understand each and everything that is happening inside these circuits. Okay, stay tuned guys. So watch next lectures to learn more about this. Thank you.